Hi, ladies and gentlemen. We are looking at notes 4.8, which are on distance time graphs and scatter plots. So let's take a look at our first scenario that we have here. It says that every morning Jim walks along a straight road from his home to a bus stop. So he's walking from his home to a bus stop, a distance of 160 meters. So that's really important, the fact that it's 160 meters. The graph shows his journey on one particular day. Describe what may have happened. All right, so first thing we need to do is look and see what my x and y axes are labeled. So the time in seconds is my independent variable. So the time is just going to keep going. The distance from home in meters is my dependent variable. It depends on how much time has gone by. Okay, so we have to talk about what happened. So right here, we'll do like a quick overview, and then we're going to go more into detail about what's happening. Okay, so over here, it's clear that he's walking away from home. So he walks away from home in this section. Then he walks towards home here because his distance is getting smaller. And then over here, he's walking away again. And then here, this is just flat, so his distance is constant right here. So this is just he's at rest. He's not moving at all. Okay, so we'll say no movement right here. Okay, so I want to talk about more specifics right here. So we can start by saying that Jim starts walking away from home because his distance away from home is increasing towards the bus stop But the question is, what kind of a rate is he going at? Well, it's constant because it's a straight line. So we can say at a constant rate, but we don't know exactly what the rate is, but we can calculate it. So at a constant rate of what? Well, it went up by 100 and it went over by 50. So we can say that in order to figure this out, I can just find my rate is rise over run, which is 100 meters over 50 seconds, which is 2 meters per second. So at a constant rate of 2 meters per second. Then at 50 seconds, something happened. He decided to turn around for whatever reason. So right here, he's walking closer to home. But the question is, what's his rate right here? Well, his rate is obviously faster because this line segment is steeper than this line segment is. So let's do our rise over run right here. So our rise over run in this section, remember, is going to be negative because it's going down. So this started at 100 and it went to 40, so it went down by 60. So we can say negative 60 meters, and then it went over by 20, so over 20 seconds. So I get negative 3 meters per second. So we can say then Jim turns around and starts walking towards home at a rate, it's also a constant rate because his line is straight, right? At a constant rate of 3 meters per second. Now, we don't need to include that it's negative because the fact that he turns around implies that it's negative. His distance is decreasing, okay? Then things start to change again. So at 70 seconds, okay, so at 70 seconds, things are changing right here. At 70 seconds, he decides to go back towards the bus stop. Now, the question is, how fast is he going? So we're going to do rise over run yet again. So rise over run right here. He started at 40 meters and he reached all the way to 160 meters, right? So he clearly reaches his bus stop at the end of this walk. So at 70 seconds, he starts going towards the bus stop again. At a constant rate of what? So if he started at 40, right here and he went to 160, his rise is 120 meters. And his run, he went over by 30 seconds. So it's 120 meters over 30 seconds, which is 4 meters per second right here. So at a constant rate of 4 meters per second. And it's really important that you guys are aware that he actually reaches the bus stop at a time of 100 seconds. So, and reaches the bus stop at 100 seconds. Okay, and then lastly, the last piece is this piece right here where he has no movement. His distance is staying the same from 100 to 120 seconds. So we can say then from 100 seconds to 120 seconds, he waited at the bus stop because his distance is staying the same. So he waited at the bus stop. And that's what you need to do when you're trying to interpret a distance time graph. Okay, now we're going to talk about a scatter plot. Scatter plots are a little bit more complicated than distance time graphs, so make sure you've got that mental stamina and you're ready to focus on what I'm going to say next. All right, now for the next question, it says this table shows the number of days absent from science class and the report card marks for 15 students. So question A says to identify the independent variable and the dependent variable. So in my chart, I see I have days absent and then I see that I have mark. So the independent variable is going to be my days absent. So the answer to question A right here, and we're going to squeeze this in because there wasn't enough room on the paper. Sorry about that. So the answer to question A is independent is going to be days absent. And then the dependent is going to be the mark because the mark depends on student attendance, right? Like if you're in class, you're going to do a lot better than if you don't show up to class at all. So the more often you're at school, most likely the better your mark is going to be. And we're going to see if this is true when we create our scatter plot. And a scatter plot is literally what it says, a plot with a bunch of scattered data. We don't connect anything, it's just a bunch of scattered points, okay? So question B says to make a scatter plot of the data. Well, if you remember, we said that the independent is the days absent, and the independent variable always goes on our x-axis. So right here, what I'm going to do is I'm going to put my independent variable of days absent right here. I'm going to label this as days absent. Okay, and then I'm going to put my dependent variable on my y-axis up here, and I'm going to label this right here as the student's mark. Okay, and if you count this up on the bottom, we have over 30 sections, but we need to go up to a maximum of 22 days. So what I'm going to do is I'm just going to go by ones, but I'm not going to label every single one so it doesn't get crowded. So I'm just going to label this 0, this is going to be 2, and I'm just going to go ahead and continue labeling my graph until I get to past 22. So I'll just go to 30. Okay, and then our marks that we have here, our lowest mark in our chart is a 38, and our highest mark in our chart appears to be a 95. So I think if we go somewhere between 0 and 100, that would be great, because it also just makes sense because you can't have a mark lower than 0 or a mark higher than 100. So there's over 20 sections right here, so I think that each block should represent 5 marks. So this would be 5, making this 10. This would be 15, making this 20, and I would just keep going. So 30, 40, 50, so on and so forth. Okay, now since our first person was absent for 2 days and got a mark of 81, I'm going to go to my graph right here, sorry, we want to make this 100. I'm going to go to my graph here, and I'm going to say 2 days absent will go with an 81 as a mark right here, and I'll put a dot there, okay? The next one that we have in our chart is that 0 days absent, the person got a 73 in the class. So I'm going to say 0 days absent, I'm going to go to 73, and that's where my mark is going to be. Okay, the next one was the student was absent for 12 days, so put a check next to these two, and got a 50 in the class. So if you were absent for 12 days and you got a 50 in the class, this is where you would fall in the graph, okay? And then the next one is 7 days with a mark of 63, so we'll put a check next to that one because we're going to do that one right now. So 7 days, 7 days with a mark of 63 goes right here. And I'm going to keep going with it. I'm not going to keep scrolling up and down because you have the information right in front of you. So another student was absent for 1 day and then ended up getting a 77 in the class. So I'm going to go to 1 day and go to 77 and put a mark there. Okay. Another person was absent for 22 days and received or earned a 38 as their mark in the class. So I'm going to put a dot right there. The next person was absent for 10 days and earned a 44 in the class. So that's where their mark is going to be right here. 10 will correspond with the 44 as a mark. The next person was absent for 3 days and earned a 95 in the class. So we'll put a dot right there. Okay. The next person was also absent for 3 days and got an 86 in the class. So, and it's okay if I have a dot for 3 at 86 and then another point at 95, totally fine. There's nothing wrong with that. The next student was absent for 4 days and got a 71 in the class. Okay, and I'm just going to keep going with my dots. The next person was absent for 8 days and got a 67 in the class. Next person was absent for 0 days and got an 88 in the class. The next person was absent for 9 days and got a 61 in the class. Okay, and then the last person was absent for 15 days and got a 40 in the class. So if you guys notice right here, we have a general downward trend. It's clear that the people with the higher marks are the ones who were absent less often. So that's what my scatter plot looks like. I'm done with question B. Okay, so question C says describe the trend of students between a student's marks and attendance. So it's really clear to see that as days absent increases, so as days absent increase, the mark tends, not always, but tends to decrease. So that's the trend between the two. Okay, then part D is the tricky part. Drawing a line of best fit. So I need to draw a line that fits this data well. So this next part that I'm going to do, don't actually put it in quite yet. I want you guys to see what I'm doing, and then I'll tell you exactly which one we'll put in. Okay, so if you guys look right here, if I have a line of best fit, here's my line right here. Does this line describe this data right here? No, it's not a good representation of this data because it's not going in the same general direction, right? So then I'm going to have a line that goes in the same general direction. But this is still not a good line of best fit because it's not within the data, right? It's not describing the data very well. It's higher than what the data is, okay? So if I were to have something more like this right here, I think this might be a better line of best fit. Now the question is, should I play around with this and maybe make it a little bit steeper or a little bit narrower? Well, let's see. If I were to make it steeper, still isn't so great. If I were to make it a little bit flatter, then it wouldn't be a great representation because it's now it's too low. So I'm thinking right here, this is probably a good representation of my data right here. So if you look right here, I think this looks pretty good. This is representing my data in a decent manner right here, okay? So right here, when I take a look at this, this is what I will end up having as my line of best fit. So now the next question is, find the equation of the line of best fit. Well, how do I find an equation of a line of best fit? The exact same way I find any equation at all. I find the m, and I find the b. Well, when I look at my graph, my b is very obvious. My b is already at 95, so I don't have to worry about figuring out what this equation or what the y-intercept is. But I need 2 points to find my slope. So I know 0, 95 is 1 point that I have. And I'm going to choose another point, but it's not going to be a data point. I'm trying to find the equation of my line. So I'm going to choose a point on my actual graph or on my actual line itself. So my other point that I'm going to choose is going to be 16. By the way, you can draw this line in. So if you need to press pause and draw this line in, go ahead. But this point is going to be at 16, 35. So that's a good point to help you draw in your line of best fit. Okay, so now how do I find the m? Well, if I know it goes through 0, 95 and 16, 35, to find my m, I just use my slope formula. So I would do y2 minus y1 over x2 minus x1. So when I go ahead and I subtract this, I end up getting negative 60 over 16. And then I would use my calculator to determine what that value is going to be. So if I go to calculator right here and I divide negative 60, make it negative, divide it by 16, I end up getting negative 3.75. So I know that right here, my slope is negative 3.75. My y-intercept is 95. So I can say that y equals negative 3.75x plus 95. Okay, but I have to make sense of this equation. So what does y represent? Well, y represents my mark. So a student's mark is equal to, it starts off, generally, we would expect that it would start off at around a 95. We would expect people to get a 95 in the class, just because sometimes they'll make some mistakes if they're in class every day. And then this right here is saying that every day that a student is absent, the mark is going to decrease by 3.75 marks, okay? So that's really important to understand what that's saying right here. So then it says use your equation to extrapolate. Extrapolate means to predict somewhere outside of the data. So right here, our data went up to 22, so anything outside of 22 we can use our equation to predict what a student's mark would be if they are absent for 30 days. Let's actually make this 24 days, okay? So if you remember right here when we did this, our days absent was x. So every time I see an x in my equation, I'm going to replace it with 24. So I'm going to say y equals negative 3.75 times 24, and then I'm going to add 95 onto it, okay? So, and this should make sense to you because if we start at 95 and then go down by 3.75 marks per day, we have to multiply that by 24 to figure out how much it went down by. So when I do my multiplication here, I'm going to take 3.75, multiply that by 24, I get 90, but it's a negative 90 because a negative times a positive is a negative. So I get negative 90 plus 95, which is a 5. So if a student is absent for 24 days, we would expect that their mark would be a 5 in the class because they're missing so much instruction. Does that necessarily mean that if a student is absent for 24 days, they're guaranteed to get a 5? Definitely not. It's just a prediction, okay? And that's everything that we need to know about our scatter plots, okay? All right, I'll see you later. Have a great day.